This is a video about one of the most important, yet least understood, concepts in all of physics. It governs everything from molecular collisions to humongous storms, from the beginning of the universe, through its entire evolution, to its inevitable end. It may in fact determine the direction of time and even be the reason that life exists. To see the confusion around this topic, you need ask only one simple question. What does the Earth get from the sun?
What does the Earth get from sun?
Well, it's light rays.
What do we get from the sun?
Heat. Warmth.
Warmth, light.
Vitamin D. We get vitamin D from
We do get vitamin D from the ultraviolet rays?
Well, there's a lot of energy.
What does the Earth get from this energy?
Yeah, it's energy.
Energy.
Nailed it. Every day the Earth gets a certain amount of energy from the sun, and then how much energy does the Earth radiate back into space relative to that amount that it gets from the sun?
Probably not as much. I don't believe that it's just radiating right back.
I'd say less.
Less. I would
Less.
say less.
I'd guess about 70%.
I think it's a fraction.
I'd say 20%.
Because we use some of it.
We use some of the energy.
We consume a lot, right?
But the thing about energy is it never really goes away. You can't really use it up.
It would have to break even, wouldn't it? Same amount, yeah.
You know, cause and effect, it'd be equal in some ways, right?
For most of the Earth's history, it should be exactly the same amount of energy in from the sun as Earth radiates into space.
Wow.
Because if we didn't do that, then the Earth would get a lot hotter. That'd be a problem.
That'd be a big problem.
So if that is the case,
Yep.
then what are we really getting from the sun?
That's a good question.
It gives us a nice 10.
It gives us a nice 10. I love it. We're getting something special from the sun.
I don't know. What do we get without the energy?
But nobody talks about it. To answer that, we have to go back to a discovery made 2 centuries ago. In the winter of 1813, France was being invaded by the armies of Austria, Prussia and Russia. The son of one of Napoleon's generals was Sadi Carnot, a 17-year-old student. On December 29th, he writes a letter to Napoleon to request to join in the fight. Napoleon, preoccupied in battle, never replies. But Carnot gets his wish a few months later when Paris is attacked. The students defend a chateau just east of the city. But they're no match for the advancing armies, and Paris falls after only a day of fighting. Forced to retreat, Carnot is devastated. 7 years later, he goes to visit his father, who's fled to Prussia after Napoleon's downfall. His father was not only a general, but also a physicist. He wrote an essay on how energy is most efficiently transferred in mechanical systems. When his son comes to visit, they talk at length about the big breakthrough of the time: steam engines. Steam engines were already being used to power ships, mine ore, and excavate ports. And it was clear that the future industrial and military might of nations depended on having the best steam engines. But French designs were falling behind those of other countries, like Britain, so Sadi Carnot took it upon himself to figure out why. At the time, even the best steam engines only converted around 3% of thermal energy into useful mechanical work. If he could improve on that, he could give France a huge advantage and restore its place in the world.